Alright, gang, let's get into a little 5-3. And this is basically going to be it for what I guess we're sort of calling Chapter 5. So in 5-3, looks like we're going to be solving polynomial equations. Now, it might sound a little new and crazy, but nothing could be farther from the truth. You've been solving polynomial equations for years. Even if you were solving like 5x plus 2 equals 5, I don't know. Like, that was only like a linear style kind of polynomial equation, but you've been solving equations that were involving polynomial. And then even like the quadratic equations, where we learned how to use factoring, that was solving polynomial equations. So I guess like the bottom line here in like 5-3, where you're thinking like, well, why is there like another section where we're going to be solving polynomial equations? What else is there to learn? You might be asking yourself. Well, basically, the simple answer is there's going to be a couple more factoring tricks that there are to show you. Okay? And the good news is I'm going to be pretty much like trimming most of them. I'm only going to really be focusing on like one of these that I want to actually, care about and focus on. Like if there was one thing I had to, we'll get to that. We'll get to that. But first, factoring and solving using a quadratic pattern. So looking at this, you might go, what the heck? But it turns out that we can treat it just like that, and we can use like an unfoil strategy to kind of factor this the same way you would factor that, and then, except it's x squared, blah, blah, blah. The point is, I'm not going to have you, as on a mandatory basis, try to learn about this kind of example. It's here, for you to write down if you want to and think about it. But I'm not picking this type of problem for our lesson. Here's another example. Of course, first you would have to, well, this was just factoring. Here's a theme. Don't forget, sometimes you're just factoring for the sake of factoring. Sometimes it's an actual equation, and you're factoring as a way to solve it. So here you'd have to set it equal to 0 first, and then you would use like an unfoil pattern type strategy. Oh my gosh. And you would get all this. Again, I'm not really picking this type of problem, but I do want to focus on this right here. I do want to point your attention to this part right here. Remember that when you're solving this part of it, like if you ever had to do x squared plus 3 equals 0, unless you wanted to do the quadratic formula, you would kick the 3 over to the other side. You would end up with x squared equals negative 3, and then you would take the square root of both sides. And remember, you can't technically take the square root of negative 3. That's why there ends up being like an imaginary component to the answer. And also don't forget about this whole that there's a positive and a negative answer. So it's plus or minus I square root of 3. So again, I don't care, right now about this whole type of problem in general, but I do want you to understand how this, specific equation was solved, and you ended up getting like this answer, okay? This, my peoples, this is what I'm picking to focus on as like the next kind of factoring. Remember, we know about GCF. we know about all the different types of unfoil examples, like regular unfoil, difference of two perfect squares unfoil, which is like special case. There's problems that require the Phoenix method, but that's still technically unfoil. This is actually a brand new type of factoring. So, and it's kind of important enough where I didn't want to skip this. I'm skipping most of 5-3. I didn't want to skip factoring by grouping. I need you to see this, okay? And this is what most of the homework is going to be about, factoring by grouping. Again, sometimes we're just factoring, sometimes we're factoring in order to actually solve for x. But anyway, here's how factoring by grouping works. It's got the word grouping in the title. So here's what you're going to do, man. I hope, first of all, that you notice that there are 4 terms. Not 3, not 5, 4. 1, 2, 3, 4. So there's 4 terms, and there's no GCF, right? If there's no GCF, right, you're thinking like, well, does it unfoil? And right away you're probably got this look on your face like, I've never unfoiled anything with 4 terms. That's because it doesn't make any sense. What I'm saying is, people, when you see 4 terms, that is a dead giveaway where you should be strongly considering this factoring by grouping. So I'll even write this down. 4 terms, baby. Okay? 4 terms, and there's no GCF. Dead giveaway. So here's what you do. You group the first 2 terms together and the second 2. So you kind of think of like these 2 terms being in their own little group, and then these 2 terms being in their own little group, okay? You kind of like split it up into like 2 groupings. Then what you do, and you might want to write down these steps off to the side, okay? So you kind of group these 2 terms together, these 2 terms are together, and then you take a GCF out of each separate pair. Even if that GCF is a 1 or like a -1. Okay, so let me say this again. We're going to take a GCF out of just those 2 terms, and then we're also going to take a GCF out of these 2 terms separately. And again, you even consider 1 or -1 to be a valid GCF. Like never before did we actually consider like 1 to be an actual GCF. That never really counted as a GCF, or -1 never really counted as a GCF. But here in this factoring by grouping method, it will. Okay? So I'm even going to skip these 2 boxes because I'm actually trying to make this even simpler than I ever have before. So what's the GCF of just these 2 terms? Just those 2 terms. Wouldn't it be x to the 2nd power? Okay? And so you take the GCF of x to the 2nd power out of these 2 terms, and this is what you get. And now here's something you might want to write down or make a really strong mental note of, or maybe even a literal written note. When you have a negative right here with these 2 terms, if your first term is negative, you need to take out a negative GCF, just like we always have. Remember, when the leading term is negative, I've said this before, this isn't new, you would include a negative in your GCF. So what's the GCF of -3x and 12? Well, wouldn't it be -3? And then when you divide a -3 away from each term, what you're left with is x and then -4. So I really want you to pay a lot of attention, and put a lot of effort into making sure you understand how I brought out a -3 because this was negative, and I ended up with a bubble of x minus 4, which is, ready? We're moving on, which is really important in this whole method because we actually need to get the same bubble twice. Like look at this. We got the same bubble of x minus 4 left over both times. Coincidence? I think not. So after you take a GCF out of both little groupings here, what you do next, okay, is you're able to come up with your final answer. So this bubble that repeated itself, x minus 4, that's going to be one of your bubbles in your final answer. The other bubble is going to be this GCF together with this GCF. So the other bubble is going to be x squared minus 3. And that's how that works. By the way, here's some fine print for you. Going from this step to this step was actually technically another round of GCF. You know what I mean? Like technically we actually brought out a GCF of x minus 4 because both of these crazy terms have a factor of x minus 4, so you can like take that as a GCF. Never mind. Like you don't need to remember that, the technicalities. Just remember that your final answer, one of the bubbles is going to be this bubble that repeated itself, and the other bubble is going to be the GCFs put together. Okay? Yeah. So again, this was just factoring for the sake of factoring. But in this other problem, notice how it's actually an equation, and we're going to be, factoring with the intent to actually solve for x. So once again, here's the steps. Get out of there. You think of these two terms being together and these two terms being together, and you're going to take a GCF out of each half, you know what I mean? So what's the GCF of these two terms? Wouldn't it be x to the third? No, never mind. Never mind. I'm going to move that one. Wouldn't it just be x to the third? So you factor out as a GCF x to the third, and what you're left with is 2x minus 1. Now, what's the GCF of 6x minus 3? The other two terms. What's the GCF? Wouldn't it be 3? So you take out a GCF of 3, and look what's left over. 2x minus 1. Exactly what we needed, So now, your final, factoring is going to be this bubble, 2x minus 1, and then the other bubble is going to be x cubed plus 3. Okay? Okay? But guess what? We're not done, because we weren't just factoring for the sake of factoring. We're factoring so we can solve. So remember, for days and days and days and days now, even maybe weeks, couple weeks now maybe, we've been, well, maybe like 3 weeks, I don't know, whatever. We've been factoring, we've set it equal to 0, so don't forget, before you factor, you got to make sure it's equal to 0. That's been the plan for weeks now. So after we have the factors, what do? We set equal to 0, we factor, this was factoring by grouping, but we factored, bottom line, and what do we do after we factor? What do? We set each factor equal to 0 separately. And then we solve each one of those equations. That's what we've been doing. So it's no different here. Set equal to 0. We factor however we need to factor. And then we set each factor equal to 0 individually. Okay? Now, solving this bad boy is easy peasy Japanesey, right? we can solve this for x like we've been doing since like 7th grade. No big whoop, okay? Now this one, here's what we would do. This is probably brand new territory for you, okay? Just warning you. So for this one, we would move this 3 to the other side, and we would get x to the third equals -3, okay? Now, if this was like an x squared, you'd be able to take the square root of both sides to solve for x, right? Well, this is x to the third power. So what we're going to do here is take the third root of both sides. Okay? We're going to take the third root. Because what's the opposite of raising to the third power? Well, taking the third root. So, I know this is brand new territory, just kind of bear with me, okay? So what is the third root of -3? Okay? Well, to be honest, that's not a clean answer. You know what I mean? Like, it's not like taking the third root of like 8. Okay? The third root of 8 is a nice clean answer of 2. Because 2 to the third power is 8. You know, like 2 times 2 times 2 is 8. So the third root of 8 would be 2. Now, let me blow your mind even more, okay? Just so bear with me. What if it was the third root of -8? So let me try to write this down. The third, this is going to be so ugly. The third root of 8, for example, that would be 2. The third root of -8. That actually makes sense. Right? Isn't -2 times -2 times -2, isn't that -8? So believe it or not, the third root of -8 is actually -2. Like we're not, this isn't like imaginary, you know, it's not like we were taking the square root of -8. That would have been like imaginary, you know, as well as having like a positive and a negative answer, by the way. But you can actually take the third root of -8. That's not weird at all. That's not imaginary. That's not crazy. That's -2. So the answer here, I'm just going to leave as the third root of -3. I mean, you see this is called like an index right here. So this symbol can mean more than just like a square root. You can use it to represent a third root or a cube root. So I'm just going to leave this answer like this because, you know, I can't take a nice cubed root of -3 the way I can take a nice cubed root of like -1 or -8 or -27 or +27. So I'm just going to leave that answer like that. Okay. And by the way, people, hypothetically speaking, don't write this down, but if this was actually an equation that we were solving, right? From this answer, you'd be getting what? X minus 4 equals 0. So from here, you'd get like x equals 4. And from this, you'd end up with like x squared equals +3. You know, after you write down x squared minus 3 equals 0. You'd end up with x squared equals 3. And then you would take the square root of both sides, and you'd end up with plus or minus the square root of 3, because you can't do a nice square root of 3, so you would just leave it as the square root of 3. Okay, but we weren't even solving there, we were just factoring. Now, I'm going to be going through the homework here in a second, but first I also wanted to just put this on the screen. I'm not picking this either. I am excusing you, I'm exempting you from trying to learn this other kind of factoring, you know? So, but I just want to make you aware of this, right? There's actually a way to factor something if it's the sum or difference of two perfect cubes, and it's actually sort of like a formula. And here's the formulas to do it. And in case you wanted to pause the video later and see if you could figure out what the heck is going on in these examples, you can be my guest. I don't want to rob you of an education here, or at least the opportunity to check this out. And if you want to talk to me about it later, whatever, but I'm not making this mandatory. But again, if you want to pause the video and oh my goodness, look at this. Actually solving for x, you get your factors, and then you had to bust out a quadratic formula here with imaginary answers. What a problem. So anyway, not mandatory. All I really care about is the factoring by grouping. So here's your homework. Let me tell you about the homework, okay? Give you some hints and pointers. Little Ghostbusters vibe right here. Who you gonna call? So there's a bunch of these I'm excluding you from, or exempting you from. Like this would have been sum of two perfect cubes, difference of two perfect cubes, difference of two perfect cubes, difference of two perfect cubes. But number 14 and 15 you got to do. So number 14 is going to be factoring by grouping. And guess what? Number 15 is an oldie but goodie. It's not factoring by grouping. You should be able to figure out how you can factor number 15, but it's not going to be by grouping, and it's one of our oldie but goodies. So, and then oh my goodness, all of these, I mean, difference of two perfect cubes, the same. This was that special one. I mean, never. Now, these ones are going to be factoring by, or solving by graphing. Okay? By graphing. So what you're going to do is you're going to jump on Desmos, desmos.com. I'll probably provide a link. And again, all you're doing here, so this is kind of a throwback to those easy problems where you can like use graphing technology. So for these, you're going to first of all make sure that it's equal to 0. Like you're going to have to set this one equal to 0. This one's got to be set equal to 0. This one's got to be set equal to 0. And what you would do, you ready? You would throw this into Desmos by saying, like for number 26, for example, you would type it in as y equals 3x cubed minus 6x squared minus 9x. Just like this one, you'd type in y equals 4x cubed minus 8x squared plus 4x. And that way, what you're looking for is the x-intercepts. Your x-intercepts that you see on Desmos, those are your answers. So if you see that your x-intercepts are like -3, 0, and 2, like that there's 3 x-intercepts, you can just write on here, type in, right, x equals -3, 0, and 2. You know, so again, you're just looking for the x-intercepts on Desmos. Okay? And then this last bunch, I just threw on a few more like factoring by grouping. So remember, people, these are just factoring. You don't have to do any solving. But these are actual equations, and so you're going to go all the way to solving for x, okay? Let me know if you have any questions.